Welcome everybody to Njord's live event on carbon capture and storage systems. My name is Fredrik Pind and I'm the Managing Director of Njord. Njord is a green technology catalyst originally ideated between Cargill, Mitsui and Maersk Tankers. And in Njord we work with ship owners and charters as their green transition partner, accelerating their journey to zero by assessing, designing and installing combined packages of energy efficiency technologies. At Njord, we deliver both technical, commercially, and also regulatory analysis, and we operate independently across technologies and suppliers with a growing portfolio of more than 30 technologies that we work with, and one of those is carbon capture and storage systems. So carbon capture and storage is what I like to call the new kid on the block, introduced in the industry to slash emissions for shipping. The ability to capture carbon directly from the exhaust gas has the potential to be a real game changer in the industry. And the potential for vessel owners to make a profit on carbon captured depends on various factors, including cost of implementing and operating the systems, the value of, for instance, carbon credits or offsets in the market, and any regulatory incentives that are introduced. While capturing carbon emissions is a positive step for environmental sustainability, the economic viability and profitability hinge on the overall cost and the mechanisms in place for monetizing or trading the captured carbon. So today, we aim to cover all angles from the different systems out there: implementation stage, effectiveness, commercial viability, and also the future outlook. And we have quite an exciting panel with us today who will do just that. Remember, as an audience, just like the previous live events we have held in Njord, you are able to post questions anytime during the event, and we will try to respond to as many of those questions as we run through the event. So don't wait until the very end to post questions. If you have something specific that you want answered, you can already now start typing it into the chat, so you're ensured that we have a chance to take a look at them. Great. With that introduction, it gives me very much pleasure to start introducing the four panelists. We will start with Alisha Fredriksson. Alisha is the co-founder and CEO of Seabound, a climate tech startup building on board carbon capture equipment for ships. And previously, Alisha, she helped build the leading electro-methanol startup Liquid Wind and launched a climate program at Generation, which is a global non-profit that was founded by McKinsey & Company. Welcome to the event, Alisha. Then we have Sören Scheid. He is the Regional Business Development Manager for Ecochlor for Northern Europe. Sören holds an engineering degree in environmental process technology from Bremen University in Germany. And he has over 13 years of experience in product management and sales of green marine technologies. And in addition to his role at Ecochlor, Søren serves as the brand manager for two innovative new technologies, Sinotech carbon capture and storage, and nanovapor VOC suppression. Welcome to the event, Søren. Thanks for having us, or thanks for being with us.
Thank you.
Then we have Yvette van der Sommen, who has an engineering background graduating from Delft University of Technology in the Netherlands. Yvette, she started her career at ABN AMRO Bank, where she was mainly involved in ship finance and where she fell in love with the maritime industry. Yvette joined Value Maritime 3 years ago and is currently the Global Commercial Director, responsible for all commercial activities within Value Maritime. Welcome to the event, Yvette.
Thank you, Fredrik.
And then last but not least, we have our in-house shipping veteran, Steen Jacobsen. Steen is the technical director of Njord, and he has been with more than 30 years with Maersk, closing in on 40, being responsible for driving results through innovation in areas of fuel efficiency, new building supervisions, and retrofits, among others. His key roles have included head of fleet technology, head of cost leadership, and fuel optimization, while also having sailed as chief engineer on all types of Maersk oil and chemical tankers. welcome to the event, Steen.
Thank you.
And then a big welcome to the entire panel. It's great to have you guys here. I'm really looking forward to it. And we'll just start jumping straight into some of the prepared questions that we have for you guys. And the very good thing to get started on, I think, is to get an overview of the systems that each of you represent. Obviously, we would like the audience to understand what is the system, how does it operate, and what is the specific carbon capture mechanism. So I'll start by posing that question to you, Alisha.
Sure. Awesome. Well, thanks again for having me, and hello, everyone. So when we started Seabound, we were actually initially technology agnostic, and we went out searching for the best type of carbon capture technology that would be suitable for ship-specific constraints. And after our whole process of searching for technologies, we ended up selecting a second generation form of carbon capture technology called calcium looping. And we are developing a specific compact form of calcium looping device. So I've represented the way that it works in very simple terms at the bottom of this one pager. Essentially, we start with a material called calcium oxide, and it's in the form of small solid pebbles. We load them into our carbon capture device, and then we also reroute the exhaust from the engine into our device. The calcium oxide reacts with the carbon dioxide to make calcium carbonate. Essentially, you can think of those pebbles as soaking up the CO2, and then the CO2 is locked within that carbonate. And then that's all we do on board. We temporarily store them on board. And when we get into port, we offload them, and either we can sell the calcium carbonate to be used as a building material, or we could post-process it on shore and essentially do the opposite reaction, split the calcium carbonate up into calcium oxide and CO2. And that way we could reuse the calcium oxide to capture more CO2 on board another ship, and then sell the pure CO2 for methanol production or for geological sequestration.
Super. Thanks a lot. Thanks a lot, Alisha. Very good introduction of your system. Appreciate it. Søren, same question basically from you. Please introduce how it works at Cyanotech and Ecochlor.
Yep, sure. Yeah, first of all, Ecochlor is a provider of maritime green technologies. We started over 20 years ago with the Eco1 ballast water treatment system, which is already very energy efficient, and recently added Cyanotech's carbon capture and storage technology to our portfolio. This can be used as a standalone CCS system or in combination with an existing or new scrubber. The process basically is that the exhaust gas passes an absorption stage, which is indicated as number 2 in the image. And in this absorption stage, we use an amine solution to absorb the carbon dioxide from the exhaust gas. Clean exhaust gas leaves the vessel at the funnel. The amine solution is stripped from carbon dioxide in this number 3 stripping stage using heat. And the amine solution is then recirculated back into the absorption stage, which significantly reduces the volume of amine required. The carbon dioxide itself is dried, compressed, and cooled, and then stored in pure liquid form on board of the vessel, which is already the preferred state of this substance for further use on land to produce green fuels, for example, for sequestration and depleted oil fields, or for use in chemical and industry, for example. The system is usually supplied with this stripping and liquefaction stage, but it's also possible to have the system without this additional equipment. Thank you, and back to you.
Super. Thanks a lot for the introduction, Søren. And then last but not least, let's hear it from Yvette on the Value Maritime system as well.
Hi, everyone. Value Maritime's filtering system and carbon capture technology can be seen as a two-step approach. So in the first step, for fuels with a sulfur content at least, sulfur and particulate matter are removed from the exhaust, and the exhaust is also cooled. This is a necessary step for carbon capture based on an amine technology, but it also gives the complete system a business case, similar to other scrubbing technologies. So in the second step, we circulate an amine-based liquid over the amine and store this all together on board of the vessel. So the CO2 itself, it's not liquefied or pressurized, and therefore the energy consumption is extremely low because we only need a circulation pump for this part. And once the vessel calls in port, the saturated amine is offloaded and either utilized directly, for example, in greenhouses, as we do today, to enhance crop growth, or processed further for sequestration or methanol production in the future.
Thanks a lot. Great. That basically recaps it across the entire three panelists here in terms of introducing their systems. What we obviously also like to hear about is then how far are we in terms of implementation? And I can see just on a side note that we already have a couple of questions coming in on the chat now that the three systems have been introduced. Don't hold back. I'll also start screening those questions and start posting them as well. But before we get there, let's talk about implementation stage. And I'll start the other way around here. Yvette, from your side, where are we in terms of implementing the systems from Value Maritime?
Yeah, so only looking at the carbon capture unit, we currently have 21 systems on the water and many in our pipeline to be installed in 2024. So we have captured the CO2 and have injected this in greenhouses in Rotterdam area. And what we are currently focusing on is the carbon logistics and the certification process. So we have this week announced a partnership with EVOS this week, where we will build 2 large tanks for amine storage in the port of Rotterdam. And at this location, we can receive, but also treat the captured carbon. And it's also very close to greenhouses for immediate use, but also close to a CO2 pipeline for sequestration. But simultaneously, we're also working on a global network, because obviously it doesn't make sense to only have an outlet in Rotterdam and have 100 vessels on the water. So we need this global infrastructure to actually make a difference. And our most recent shareholder, Shell, really helps to accelerate this process. I think we need all hands on deck to have this infrastructure in place as soon as possible.
Okay, thanks, Yvette. So if I hear correctly, 21 systems in water, a good pipeline for 2024, but still quite some focus needs to be done on the infrastructure side. Yeah.
Exactly. So the ship side, that's more or less done. So it's really now on the shore side and the infrastructure. Exactly.
Got it. Thank you. Søren, moving over to you from Ecochlor side, where are we on implementation when it comes to your system?
Yeah, generally speaking, CCS is not a fancy new technology, but it's already in existence and in operation. Sinotech's parent company, Sinopec, already has over 50 CCS units in land-based operation, some of them since 2020. So they already have a lot of experience and are capturing millions of tons of carbon dioxide per year. With respect to the maritime application of CCS, the first vessel, 95,000 deadweight bulk carrier with the CCS, with the Sinotech CCS system, will be commissioned this coming January. So this is also going nicely. And a second Greek-owned bulk carrier will receive a Sinotech CCS system in December 2024. And interestingly, the first one is without this stripping and liquefaction stage, while the Greek vessel is including the full scale, capable of capturing around 46 tons per day, and with tank capacity giving it a 30-day cruising range.
Super. Thanks, Søren. You bring up something very interesting here in terms of the onshore application and the fact that the technology has actually been proven and working for many years onshore, and now it's time to move it offshore. And then that brings us back to Yvette's comment around building the infrastructure for that. But also very interesting to hear that both a UK-based owner and a Greek-based owner have ventured into this. Super cool. Thanks a lot. And then we'll jump over to Alisha. Same question around the implementation stage for Seabound.
Yeah, absolutely. So we're just wrapping up our first pilot project, which we conducted together with Lomar Shipping with funding from the UK government. We haven't actually shared too much on this publicly yet, so look out for an announcement in the new year. But at a very high level, we installed our first device, which you can see behind me over here, on a 3200 TEU vessel. And this was really to get out there as quickly as possible, contained all of our equipment to a few containers that we had on deck. And then the Seabound team actually took turns sailing on board and operating the device really to get that hands-on experience. So yeah, more to come on that soon, but it's live, it's out on the water, and it's working.
Super. Thanks for sharing that with us today. It's almost like we're breaking news, but not completely. But that is good to get some insights. Thanks, Alisha.
Oh.
Great. So that's in terms of implementation from the different systems. Then I would like to turn it over to you, Steen. I mean, Steen, you work with just about any kind of technology that can improve the efficiencies on the vessels. I mean, how passionate are you about carbon capture, and how big of a deal do you foresee that this will become in the industry?
Yeah, you're right. I'm passionate about anything that can reduce the energy demand on board or remove emissions, particularly CO2. I see onboard carbon capture as one of many solutions that shipping will need to adopt to properly fulfill the requirements on decarbonization. So green fuels is going to take us, or some ships, part of the way. Energy saving devices are going to enable that and reduce the amount of CO2 remaining for energy demand on board. And then carbon capture is a very good technology, particularly for vessels that are difficult to optimize further on due to their operational profile. I see them as being early adopters of this kind of technology, but we are going to see in the shipping industry different kinds of technologies for different kind of vessels on different kind of operational profiles, and we need any tool that we can get our hands on to achieve the targets of decarbonization. So I see this as a very promising and necessary technology for shipping industry.
In combination with all the other technologies that are being developed at the moment, basically.
Absolutely, yeah.
Okay, great. Thanks, Steen. And again, thanks to the audience for already now starting to post a lot of different questions. There is actually one which I think is super relevant, and we'll just jump into that one straight away. So I will post it here. It's from Alberto. Alberto is asking, what is the percentage of the captured CO2? So this is crucial and quite interesting, and a good question to ask the panelists already now. So I'll start with you, Alisha, in terms of percentage of captured CO2 from this initial pilot that you mentioned before.
Yeah. So yeah, I guess I'll comment on the pilot and then also what we are developing. So for our pilot system, yeah, we've been able to capture CO2 at 78% efficiency so far. So for this one, we were processing a slipstream of exhaust, not all of the exhaust, but of the available CO2 in the exhaust that we were processing, we captured about 78%. So it is, yeah, pretty high efficiency. Of course, we want to increase that even further. And now we're working on building a bigger, better device so that we can process as much or all of the exhaust and capture as much or all of the CO2. Theoretically speaking, the sort of theoretical maximum for our technology is 95% capture. So we could capture that amount of CO2 on board the vessel. But I think it really depends on, first of all, if the owner wants to, right? If there's enough of an incentive to do so from their customers or from their regulators. And then also it would depend on the voyage length and the vessel size. And of course, yeah, the nature of that ship. But there is space on board. We could fit it on board. It just depends on the incentives to do so.
Super, great. And we'll jump into the storage in a minute, because I can also see that there are comments coming in from the audience here around storage. So we'll jump into that. But thanks a lot. 78%, and then in theory up to 95%. That's quite encouraging to hear. So let's just roll this out and start capturing that carbon, right? Let's jump to you, Søren, in terms of percentages that you're seeing for the system, or at least envisioning for the system to come.
Yeah. Well, technically, we could also capture 90 or 95% of the carbon dioxide, but then hardware and also amine solution volume would significantly increase. And of course, also the volume and mass of carbon dioxide stored. So at the moment, with the project that we are doing right now, capture rates are usually 25 to 30%. Because that very nicely balances the weight of fuel oil burned with the weight of carbon dioxide captured. So there's no loss of cargo capacity during the voyage.
Super, thanks. We'll jump more into the details of the cargo capacity, but thanks for sharing, Søren. So I heard 25 to 30% is what you're operating with at the moment. Let's jump to you, Yvette. 21 systems in the water. I mean, what are the numbers in terms of captured carbon here?
Yeah, so some part is actually the same as what my fellow panelists are also saying. So in theory, we can go up to 90% carbon capture rates if there's no sulfur in the fuel. But for what we currently do is up to 40%. So all vessels equipped on the water now have between 20 and 40% carbon capture rate installed.
Say that again, sorry, how much percentages?
Yeah, 20 to 40, the majority around 30 something, yeah.
Okay, super. Thanks a lot. So encouraging and numbers I like in terms of the theoretical number where we get very close to 100. But at the moment, what we see from installations somewhere between 20 to 40, that also matches your 25 to 30% from your side. So thanks for asking the question, Alberto. Then we will jump into the storage bit, and we actually have quite a number of questions related to that as well. How much space volume is required to store the captured CO2 on board the vessels? This is a question coming from Nakul. I think before jumping into this, the three different solutions, Steen, we always touch upon the crew's role in terms of managing these new technologies here. And storage capacity, I mean, do you see this as a potential deal breaker or an additional responsibility that will be tricky for the crew to operate with?
I don't see it as a deal breaker at all. It is, very close to the scrubber technology with an added system. Obviously, if you start cooling and compressing the CO2, there will be some skills that needs to be updated a little bit for some crew members. But it's known technology, and engineers on board vessels, they deal with all kinds of technology, and they're not afraid of it. And it's pumps, compressors. Stuff like that. It's known equipment for the crews. So I'm not concerned. Yeah.
Okay, that's good to hear. But then if we are capable, then let's start talking about how much storage it actually takes up and how we will manage that accordingly. So we have a very similar question here also for George, the same lines. What about the space on board required for such systems? Can, for instance, a handy bulker install a carbon capture system? So maybe for the panelists here, as we run through, both reflect a bit around how the storage is being managed and also how you see application on different types of vessels. I would like to start with you, Yvette, for your comments on this.
Yeah, so what we do not liquefy and pressurize the CO2 itself. So we keep the CO2 absorbed by the absorption liquid, and amine in our case. So the advantage is that the energy consumption is very low, because the liquefaction part, that is the huge energy consumer. So, but of course it has and also another side of the medal. So we slightly need more space required on the vessel. So to give you an idea specifically for this question, and handy bulker, What we did for another vessel, which has similar engine capacity, I assume, compared to a handy-sized bulker, we have converted a 770 cubic meter fuel tank. And in this tank, we can store around 200 metric tons of CO2.
Okay, got it. Can you put that into context in terms of, we talked about before, percentages of carbon captured and voyages, etc. I mean, just to give it, let's make it as concrete as possible in terms of, can we then go out for which type of voyages capturing what kind of percentages and what's actually room for in the vessel?
Yeah, so for this specific vessel, the calculation was that they wanted to capture 40% on a 10 days or transatlantic voyage. So they burned 20 to 25 tons a day, 40% capture rate, and they needed a 770 cubic meter tank for this to capture the 40%. Yeah.
Okay, got it. Thank you, Yvette. Let's pass it over to you, Søren. Same question here. Space on board for storage. What are the reflections from Sinotech?
Yeah. Well, typically CCS is used in combination with a scrubber, so there would be some extra equipment required, and it depends a bit on available space on board of the volume. But I don't see a huge problem to put a CCS system, even including liquefaction, also on board of a handy-size bulker. Generally speaking, the addition of liquefaction is some extra equipment and some extra energy demand. Still, the total additional power demand for CCS, including liquefaction, I would say is somewhere around 4.5–6% maybe of fuel consumption. So the it is manageable. It's not an outrageous amount of energy that is required, and storing pure carbon dioxide is definitely the most efficient way to store carbon dioxide, because each ton of carbon dioxide is around a cubic meter of liquid CO2, so that's very energy efficient. In case of this Cape-size bulker, for example, we have initially 750 cubic meters storage capacity for the carbon dioxide, and that would be around 15 days voyage possible.
Okay, great. Thanks, Søren. I will definitely get back to the statement of 4 to 6% fuel consumption to have the system running. And Steen, I'll pitch that over to you in a minute in terms of how we can then offset that. But before that, let's talk about storage from your side as well, Alisha, and how you see this.
Yeah, for sure. Yeah, and I think there is a question both on space for the device and then space for storing the CO2. So for our system, we have quite a minimal footprint for the device itself, and that's one of the reasons why we chose this second generation calcium looping device. We're developing, as mentioned, this really compact version of it. We don't need pre-treatment equipment, we don't need post-treatment equipment, so it's pretty simple. And the more CO2 you want to capture, it doesn't scale linearly, right? So it doesn't need to be that much bigger to capture more CO2. So space-wise, we could definitely fit one on board a handy. I think the question then is, how much CO2 do you want to capture, and for how long is that voyage? And so I think, as to make it concrete, as a case study, we were looking at a Cape-size iron ore bulker, so carrying iron ore from Australia to China, about a 10-day long voyage. And for a 50% capture rate, we need about 0.5% of cargo capacity to store the captured CO2 on board in that pebble calcium carbonate form. So technically speaking, very possible, but again, you do need an incentive to give up that little bit of cargo space to store this on board. I think for a handy, if you're trading sort of on a tramp route, maybe a 30 to 45 day long voyage in between bunkering, that's where maybe you want to capture 30 to 50%, or maybe sort of cap it at about 50, so that you don't risk holding the CO2 on board for too long when you don't know which port you're getting off to. So I don't think it's just about the sort of technical constraints of a vessel and how much how much capacity we might take up, but it's also about the operational profile, and therefore how big we should make it, depending on how frequently we'll be stopping and where we'll be stopping.
Great. Thanks, Alisha. And you touch up on something as well. So what's your incentive of storing and how much you would store? And we will also jump into the regulatory space during this event as well as we go along. But Steen, I'll pass it over to you. So I mentioned 4 to 6% fuel consumption for the system to run. I mean, what do we do about that, right? Because what we're trying to do here is lower the consumption, but then suddenly we put on a system that requires even more consumption to run. I mean, how can we tweak that?
We can treat that like we do with other technologies that require energy to further optimize the performance of the vessel. That could be rotor sails or air lubrication. So it's the same approach. Number one is it's always a good idea to optimize the vessel to the extent possible and free up some energy that can be used for this particular technology. So we can lower the energy demand from the generators in service to free up enough capacity to preferably run only one generator while the system is in service. It will also so basically the trade-off between adding consumption to get a benefit is it's normal. we do that all the time in other technologies. So it's a balance, and you have to design it for the particular vessel, the particular trade profile of the vessel. We hear that from all the panelists, that there's a very holistic approach to how much should you capture depending on the voyage length and storage capacity and so on. So it is definitely a design requirement where you have to think in all these elements and only do it when it makes sense. And that's kind of the name of the game here.
Okay, I mean, this sounds good. I hopefully, and I also know from the different business cases and the technology combinations that we look at for the different owners and charters, that 4 to 6% finding that through other technologies is definitely doable, and even more so. So I guess that's encouraging to hear. But it also sounds complex, and I think I'll jump to the next question here to talk a bit about business modeling and the complexity. Because I think this is actually a good question. I'll start with you, Steen, around some of the elements to consider, and then we'll jump into the different systems in terms of how is the business case currently and what we would like to see it evolve into. So there's a question here from Taha. Does a ship owner have to completely change their business model to adapt these new technologies of decarbonization? Steen, from your perspective, when you interact with a new client, a ship owner or charter, what are the decision elements that they look into for considering to apply, for instance, carbon capture or some of the other more novel technologies on their vessels?
Yeah, but it's back to the same thing. What we do at Njord is we look at an individual vessel on a specific operational profile, and then we match technologies to that. So we don't suggest to change the business model completely. I don't think that's realistic to do so, because it's a money-making business and you have to stay competitive. So obviously a ship that's trading in North Atlantic, lots of wind, it's very interesting to look at wind technologies. In the beginning, with the limited infrastructure for the carbon capture systems, it will be looking at vessels that are trading in optimal areas for that, and then it will evolve organically as the infrastructure also improves. So it will be eligible for certain vessels on certain trades in the beginning, and then it will expand. And it's just another technology in our viewpoint that we have to match to certain vessels on certain trades.
Okay, thanks, Steen. We'll stay on this a bit in terms of how it fits into the value chain and remembering you could say the financial business case behind it. We have another very good question here. So how do you see onboard carbon capture fits into the CO2 value chain? Can this be an additional revenue for ship owners as the demand for CO2 increases, either for industrial applications or sequestration through government subsidies? I think this is super interesting to talk about. So how can we build this into a viable, positive business case for the ship owners? Alisha, I would like to start with you, your reflections on this question.
Yeah, this is an awesome question. So I think, as was alluded to in my introduction as well, I previously worked with an electromethanol startup called Liquid Wind. So they make fuel for ships out of captured CO2 and green hydrogen. Ironically, they didn't know where to get the CO2 from as they were looking to scale their facilities, especially to expand globally. And that's actually where the original founding insight for Seabound came from. It was essentially this sort of solution to e-methanol production's supply chain constraint. Of course, as we started looking into it, we realized there's much more to onboard carbon capture than just that. But I do think there's still something really compelling and exciting to that. And so essentially, we can sell the CO2 that we capture to make fuels. And if you imagine the vessels that are then burning those fuels, capturing CO2 again, we could eventually create a circular fuel system, or even in the long term, perhaps even a carbon negative system, depending on the original source of the CO2. So I think the prospect of carbon negative ships is hugely exciting, and one of the reasons why I work on Seabound personally. To make it a little bit more concrete of where this could be real, I think what's exciting is about markets where there isn't already accessible CO2, which currently is most markets. But I think in the future, it might be, perhaps it's somewhere in the Middle East, or maybe it's in Latin America, where there's been a little bit less land-based CO2 capture. And I think the prospect of turning a port into a circular fuel hub and then a methanol production hub is really exciting, because then we can create it locally, supply the ships already at ports, and we don't have to worry about transporting the CO2 long distances as well. So I think it can definitely fit into the CO2 value chain. It's just about looking at where will our price for CO2 be competitive with other sources of CO2. And my hypothesis is that it's in these sort of lightly less built out or lightly less serviced locations for existing land-based capture.
Okay, thanks. That was a very good answer, Alisha. We'll also be jumping into what some of the regulatory affairs are doing to support this, both EU and IMO. But just the overall concept of making this circular sounds extremely intriguing to me. Thanks a lot for sharing, Yvette. Your perspectives and reflections on this question here.
Yeah, I think I've not a lot of things to add to Alisha's indeed very interesting view on this, and I think she covered most of the aspects here. But the only thing I can add is that if there is not a business case, so if it's not attractive for ship owners, either from because they're pushed by regulations or because there is a financial gain to be achieved, it is very difficult for ship owners, or for us also, to get this to get our systems sold. So it is actually a requirement, and if that's not there, ship owners will not use it. They can say, or people can say, they want to install our carbon capture system or others, or other energy saving devices or whatever, but if there's no business case, it will not work, right? So that's one thing. And the other thing is that we should also step away from seeing CO2 as a waste product. And also for ports, it's a huge opportunity also for a lot of ports to treat this as a commodity and make a business case out of it. And I think we should not forget that element as well.
Super, and I like that statement in combination with Alicia's comments. So again, making it circular, don't see it as a waste product, but actually see it as a commodity. Very interesting thoughts here. But we also know shipping industry, and I believe that there needs to be some kind of incentive and the positive business model. It's easy for us, at least in Njord at the moment, to help them assess, if you apply this technology, you'll save this much emissions, but that also means saving this much fuel. So there's an easy business case calculation behind adding those technologies to the vessel, where it's a bit more tricky here. Søren,
can I add one small comment, because this is indeed a little bit for the longer term, right? And I think in order to get there, you need something to penetrate the market today, to have a business case today, because EU ETS will come into play in January, but on a global scale, we are still lagging behind a bit. But in order to be ready once it is fully recognized, and when the infrastructure is there, we also need a business case today, because otherwise we keep on having running into circles, right? Chicken and an egg story. So that's also important to have.
Yes, fully agree. And maybe you can piggyback on that, Søren, when you also reflect on this question. But I mean, you also have you could say the scrubber story. It's a bit of a way to get a head start on this, to focus on one element of the system, but then be ready for the future. But maybe some reflections on that, and also the question in general from your side, Søren.
Yeah. I mean, the scrubber, of course, immediately helps to finance the installation of such a system, because you have an immediate benefit from lower fuel prices. But following this pathway along for manufacturing green fuels is, of course, very important. Sinotech themselves are active also in the development of cryogenic membrane tank containment systems and also gas liquefaction systems. So there are some pilot projects already going on in China to produce green hydrogen transported to the densely populated coastal areas, and then use it in combination with captured carbon for methanol production, which of course is in strong demand also for shipping industry. And interestingly, I know that some of the larger ship management companies are actually considering in the future running vessels on green methanol and using carbon capture technology to actually make their vessels carbon negative, and thus not having to buy emission certificates, but they can start selling certificates. So that's also, I think, a very interesting business model. Not something that will happen in the next few months, but something certainly to look out for.
Okay, great. Thanks for sharing some good answers across the board here in terms of this question specifically. I would like to just maybe in connection with this jump a bit into the regulatory space. I'll start with you, Steen. I mean, do we see that the regulatory instances such as the EU or IMO is doing enough to push a technology like carbon capture, or is there still a pathway to go? I'll pitch around in the panel as well, but your high-level reflections on this, Steen, in connection to the importance that you believe that carbon capture will have to play in the transition to zero.
Well, the fast answer is regulation is generally always a little bit too slow, but there is work in progress and within the EU and IMO on accepting carbon capture as a technology that can be credited properly. Today, it's only what you burn that you're looking at, and not what you do with the exhaust gas afterwards. But I believe during next year there will be certain incentives approved, adopted. But I think it's going to take longer time for the broader regulation to pick up. But I'm super curious to hear the reflections from our three other panelists on this one.
Yes, me too. Thanks for that intro, Steen. Then Yvette, let's jump to you from the EU perspective, right? So you mentioned it just before. The EU ETS kicks off in just around the corner. It's getting very close now. So are we incentivized if we put carbon capture on our vessels through the EU ETS scheme?
Yeah, so under EU ETS, carbon capture is currently recognized if the CO2 is chemically and permanently stored. So then it is recognized, but it's important if you do carbon capture that you look at the whole value chain, right? So look at if you capture 1 ton of CO2, it doesn't mean that you actually can deduct this from your actual EU ETS credits, right? So you should look at the whole value chain. So there again, looking at your fuel penalty is really important. So make this process efficient. We do this processing part if required at land, so we can use renewable energies to do so, which will actually financially benefit the ship owner as well, because you can deduct more under your EU ETS credits.
So right now it's deductible if you permanently store the CO2, but how about if you then put it into a circular environment as described before? I mean, is that then covered under current regulations?
Well, from January 1st, not yet, but they're working on a delegated act for utilization to be projected to be done before the end of next year. I understand that it's a bit more complicated to write this delegated act, right? Because there's so many ways for usage, and all these usages should be written down and clearly defined. So my impression is that they start with this permanently and chemically bound, and now the next step is to also apply it for utilization.
Okay, great. Interesting. So we're still catching up a bit when it comes to the regulatory bit, at least from the EU here. Let's talk about the IMO as well, just before we move on. And I would like to pass that question to you, Alisha. Your reflections on where we are regulatory-wise from the IMO compared to carbon capture and how that is supported.
Yeah, for sure. So I'm a little bit biased, but I believe that at the IMO, it's a question of when and not if onboard carbon capture will be recognized. And I have good reason to say that. So over the past 3 biannual MEPC meetings, there have been proposals put forth by flag states from many different parts of the world, proposing that the CII calculation is amended to basically account for CO2 that's captured on board. So there's been increasing and sort of building momentum and pressure to get the IMO to consider this. I think as many UN bodies, the IMO has been pretty bogged down in recent meetings, and so they haven't really had a chance to fully dedicate enough time to it. Although it was passed and delegated to a working group in the last MEPC meeting that happened in June, I think it was. So I think there is momentum. It's not going to be a new topic the next time it's raised. Again, it's kind of been on the table for 18 months now. So I think it's just really a question of timing. So I think it's promising. And I guess just to add on to the EU perspective as well, I think it is really encouraging, and it's an important precedent that the EU has already recognized onboard carbon capture. So I do think there's a bit of a relationship between the IMO and EU regulatory frameworks. For us, right, if we bind the CO2 into carbonate, that's already permanently and chemically bound. And then on the point of utilization, it's really a question of carbon accounting rather than technical feasibility. So if the fuel user can reduce their allowances, as long as they pay us for the CO2 feedstock, then we're fine to use that system and to capture the CO2 on board. It doesn't necessarily have to be used only to reduce allowances on the ETS. Again, it could be to make money from the CO2, and then somebody else can reduce the allowances if they use the resulting fuel.
Got it. Okay. Thanks for the reflections here. So again, there is work ongoing, and it's a good push that the EU has recognized at least carbon capture under their scheme for when it's permanently stored, and that potentially is also a push for the work that's currently ongoing for the IMO. Okay. Thanks a lot, Alisha. Then we have a couple of questions around alternative fuels or fuel use in general and how that is combined with carbon capture. I'll start with you, Steen, because I know that through your day-to-day work, you're also asked to assess new buildings, dual fuel vessels, etc. And so the question here comes in terms of, is then carbon capture something that you assess for the new projects that you are taking a look at? I'm going to flash up 2 questions here, which are somewhat interlinked before I'll take a round, starting with you, Steen, and then for the rest of the panelists. The first one here from Richard: does this mean that future fossil fuels are okay now? Not the big evil anymore, since we can now remove SOx, NOx, particulates, and now carbon, at least once we get from the current typical 30% up to 95%. So it's clean fuel. Just keep this question in mind. I have one more other that I want to show. There we go. We have this one here as well. What are the candidate fuels that will be combined with carbon capture and storage? Is it technically feasible to have carbon capture with scrubbers? I think we covered that already, but LNG or methanol. So Steen, starting with you, and then we'll take a round.
Yeah, well, definitely we do consider carbon capture when we are looking at new build specifications. So it depends on what type of vessel we are looking at. What type of carbon capture would be the smart move for that particular type of vessel, and what is the fuel that is expected to be used? Obviously, if you have an ammonia-driven vessel, there's not much sense in capturing carbon. But for methanol, even fully green methanol, as explained before, you can go carbon negative. and create a business case around that. So that's still a viable solution. I would not say that fossil fuels are then okay as such, but I think we all recognize that we cannot turn into green fuels, all of us in shipping, the next many years. So fossil fuel will be an element that we have to deal with. And if we can convert some of that CO2 that we capture into the green fuels and keep the adoption of green fuels alive and accelerate it more, I think it makes a lot of sense. So any fuel that contains carbon, you can capture the carbon afterwards and reuse it or store it.
Okay, great. Thanks for that answer, Steen. Søren, your reflections on these two questions here and Steen's comments?
Yeah, I agree. In an ideal world, every ship would immediately switch to carbon neutral green fuels. But as of now, they are not available in the right quantity and at the right locations, and prices are very high. There is just no green power available to produce green fuels for shipping. And shipping is not alone in this energy use, but there's also demand from land-based transportation, from industry. So it will be a very long time until these green fuels are available. And in the meantime, we have a huge fleet of existing vessels, which are already quite high in efficiency using fossil fuels. And to have some chance at all of reaching these greenhouse gas emission targets, CCS is vital. And it does not make fossil fuels a clean fuel completely, but it definitely helps to overcome the negative impact of using fossil fuels in a financially and environmentally sustainable way. So yeah.
Thanks, Søren. I think we'll stick with the financial bit, because I can see we're still getting some questions in on the financial aspects of the business case, and maybe we need to get even further detailed on the answers here for those. I'll just take this question down, and then I'll pop up with at least one other here that's a bit more related to this. It's from Ross saying, hello, could you expand on the downstream uses of the carbon or the captured carbon? Which industries would use this and for what purposes? Is it cost effective, and is there a demand for it? I think that definitely links into the business case. We also have questions related to the actual return on the investments. So is there, if not now, then a long-term a good investment case here that you foresee? Maybe let's go into the details of it. Where does it end up, and how are they incentivized? Or at least what is it that we envision for that? Yvette, maybe you could start this one off.
Yeah. So again, this has a short-term and a longer-term view, right? So today, as I said a few times, the main business case today is on the exhaust gas cleaning system. To get back to the previous questions on if this makes fossil fuels okay. No, I hope we can go to non-fossil fuels as soon as possible. But as mentioned also by Sören, that's not realistic, right? So today, the business case for us is mainly the exhaust gas cleaning system, and the add-on of the CO2 capture bits has a business case on its own. Because today we sell the CO2 to greenhouses. So that's where the business case comes from. In longer term, but that's not operational yet at scale, at least. Obviously, as Alisha also said, we can use it for methanol production, even in food industry, in hospitals. There are many sources, many industries which need CO2 as a resource. But whether or not it's recognized under regulations, that's a different thing, right? For hospitals, it's usually regarded as short sickly. So all these things needs to be taken into account, but there are definitely a lot of industries who need the CO2, but it's a bit longer term. So that's why today, I think we should look at the options today, and greenhouses for us is a very good option for this business case.
Thanks, Yvette. It's very much linked also to the question we had here, right? Given the cost considerations in the maritime industry, how do you assess the financial feasibility of integrating carbon capture technology into existing fleets, and what return on investment can ship owners expect? Now we heard a bit from Yvette's side here. Any additional comments to what you've shared so far, Alisha, on the business case? Because it is maritime. We just want to see that business case and that return on investment. I mean, when will it materialize, and what will it take for us to get there?
Yeah, for sure. Yeah, I do think maybe similar to that. I think there's sort of a future state and a current state, which I actually don't think are that far apart from each other. Future state, we're on track to make onboard carbon capture the cheapest way to reduce emissions from your fleet. And I think that's especially true for the existing vessels on the water that will not be, retrofit with dual fuel methanol engines, for instance. And so I think, and then reducing emissions is obviously critical in order to continue operating your vessels, both from a regulatory compliance perspective, provided that the IMO does recognize it soon upcoming. But then also in terms of remaining competitive. I think if you don't offer green ships to the market, owners will struggle to charter their ships, sell their ships, finance their ships, etc. And so you can no longer have sort of business as usual non-green vessels on the water. And as long as onboard carbon capture is the cheapest way to do so relative to new fuels, or even as we've talked about, the only way to do so, given that those fuels don't exist yet, then I think the business case is really to continue operating your vessel as usual, to continue buying and selling vessels as usual, and having sort of the almost entry ticket to do so, given the onboard carbon capture system that you've got on board. That's the future state. Current state, again, not too far away, but I think it's really getting ready for that future state, right? It's investing in technologies today so that you can future-proof your fleet and get ready for that world. So for instance, for owners who believe in that future state that I've just talked about, I think onboard carbon capture will become a hot commodity very soon. We're all still relatively early stage, but we're developing very quickly. And so if you as an owner can get your hands dirty ASAP on these technologies, so you have experience operating them, you build relationships with suppliers, and then you're ready to scale it across your fleet, I think you'll be in the best position for that upcoming state that I described.
Thanks. And I guess, thanks a lot. That's a very good comment. And Søren, I'll definitely pitch it over to you. I would also assume that the collaborations you've set up with the UK and the Greece-based owners, that's exactly what they're also trying to do. But Søren, your reflections on this one here?
Yeah, to me, this whole CCS situation at the moment has similarities to the introduction of electric cars. So initially, owners were asking, why should I buy an electric car? I cannot charge it. And on the other hand, electricity providers said, well, why should I set up charging stations? There are no cars. And we are at the brink of stepping over this stopping point, basically. And this is gaining a lot of momentum. There are an ever-growing number of on-land CCS projects. There are more and more CO2 terminals being developed for permanent storage of carbon dioxide. And it's now all of those bits and pieces falling into place. So at the moment, there are indeed a number of questions regarding the business model and how the carbon dioxide is going to be used, and also regulatory questions. But all of these will be solved very quickly. It's only minor components that are still missing. And considering the retrofitting cycles, dry docking schedules for vessels, it's now a very good time to look into carbon capture technology for ships, to be sure that your vessel is future-proof for the coming years, because the infrastructure will develop, and as was said before, regulation is going to change and to factor in carbon capture as well. So this is definitely going to be a very hot topic.
Yes. Okay. Thanks for adding on, Søren. Some very good reflections on current state and future state. I like the stay competitive part of this discussion here, and get your hands dirty so you're ready for the next steps. I think there's one comment that we touched upon it very quickly initially, Steen, but I think that the audience also wants to hear a bit more around how does this fit in to everything else that is out there today and your reflections on that. So based on your experience, and thanks for raising this question as well, the increased ship efficiency and installation of ESDs such as rotor sails, dual fuel tech, fuel optimization systems will benefit the near future advancements of carbon capture and storage. How do you see that, Steen, those two playing along and being beneficial for the implementation of carbon capture?
Well, in any case, if you can reduce the energy demand on a vessel, so reduce the fuel consumption, and you maintain your carbon capture removal percentage, of course, you actually have an even better performance of the vessel. So they go very well hand in hand. I don't see any conflicts at all. It can be for some of the systems, the energy requirements for the vessel can be challenged if you don't add a PTO or something to the vessel. But most of the energy saving technologies that are available today, including performance optimization, will go very well hand in hand with the onboard carbon capture, and will only increase the overall reduction of CO2 even more. So no conflict.
Thanks, Steen. I'll stick with you. The next one is definitely also for you with your number of years of sailing experience, because I like to think about these systems as you just push the button, right? And we also talked about initially, you could even tweak how much carbon that you want to capture for the different voyages, etc. Right? So we talked about you could say both the storage management from the crew, but also managing these systems. What's your view currently, Steen? And we'll take it around for the different panelists as well around the specific systems. But how easy is it for us to implement this on board and then ask our crew to operate these systems?
I think we touched upon it before. I don't see this being more complicated than other equipments that we have. Maybe on the contrary, it's basically a scrubber with some additional pumps. So maybe our suppliers can come with some actual operating experience, but I do not foresee this as, compared to a ballast water treatment system. I think this is much more simple with carbon capture. So
okay, that's interesting. Good with the comparison. Yeah, that's not bad. Søren, let's start with you. Can I just jump on board a vessel and then push the button and then the vessel will start capturing the CO2, or how does it work?
Well, as a manufacturer also of ballast water treatment systems, I would say that at least the Eco 1 system is very easy and simple to operate, and it's designed for reliability. But on the other hand, yeah, I agree. If the crew is able to operate a scrubber, then they can also operate a carbon capture and storage system. So
yeah, cool.
Shouldn't be a problem.
Same reflection from your side, Yvette?
Well, I think there's a difference in capturing the carbon part. So that's not a difficult thing. Capturing carbon, same goes for Sören and for ours, and to also the same extent, I believe, for Alisha. But capturing the carbon, that's not that difficult, right? You use a material to absorb the CO2. It's not very, there can be some efficiency gains, but it's not that difficult. But the removing the CO2 again from the material, that's more complicated. Specifically, if you want to pressurize, liquefy it on board, there are more steps to be taken into account. Specifically for vessels which do not have, for dry bulk owners, for example, it's an additional step, which requires energy and additional training for the crew.
Okay, thanks. Yeah, Søren, follow up here.
I think this point goes in my direction because we are the ones with the separation and liquefaction stage. Energy demand, yes, there is an additional energy demand. It's not that huge. I mean, Sinotech has a lot of experience. They developed a special amine solution, which already has a 25% lower temperature demand for stripping, for releasing the carbon dioxide again, and also a very efficient heat recovery process. So as I said, the total power demand to run a CCS system, for example, for this Cape-size bulker is 4.5% approximately. Complexity of the equipment, yes, there is more equipment, but on the other hand, the stripping stage is again basically like a scrubber. You also have the amine solution raining down, and heat is used to release the carbon dioxide, so that's not magic in operation, and also the liquefaction stage is not terribly complicated. So it is definitely doable, as the Greek owner, for example, also says, yes, this is something my crews can do. So we already discussed that, and he's confident it shouldn't be a problem.
Okay, super. Thanks for the answers here. We have a lot of questions coming in, so I'll just keep us taking around on those before we start slowly moving into the roundup as well. I think this one is also quite interesting to get up here. So we have offshore oil and gas platforms have the potential to play a significant role in carbon capture and storage efforts. Can you share insights on how these existing offshore assets can be repurposed for carbon capture and storage initiatives while ensuring safe and efficient operations? I don't know who would take a first step on that. Alisha, you're nodding your head. Can I take a bet on you?
Yeah, I can try. Yeah, I mean, I think it's similar to depleted oil wells, like onshore, right? Where essentially we're reversing the process, pumping the CO2 underground and permanently storing it there. We've talked a lot today about utilization and turning the CO2 into fuels, which is definitely exciting. I think the long run is that hopefully we're in this world where we're capturing more CO2 than we can use, and we need to start storing it. And that for us is really the end game. And that's where I think existing facilities or existing assets can really help to catalyze and accelerate that type of sequestration effort. There's also been a lot of discussion in the industry about having dedicated CO2 carriers instead of needing to build pipelines for transporting CO2. And I think that's where offshore assets could also be interesting. I can imagine collecting the CO2 at a particular port. So you have kind of a in-between logistics hub for the CO2, and then it's transported to an offshore asset, and then it's pumped underground. And maybe it's carrying CO2 collected by many suppliers like all of us on this call today. So yeah, I definitely think we should stop pulling it out and start reversing the process. And if we can leverage these assets, then that'll make it more cost effective.
Yes. Thanks, Yvette. Any additional follow-up on this one here specifically?
No, not specifically. I think it makes a lot of sense, right? To use the existing platform already out there. It makes a lot of sense. I think it is important to look a bit on how far you're going to transport it, right? I think it should all make sense on the whole value chain, not transport it thousands of kilometers to a specific underground storage location. I think we should really look at these kind of things, and that's a little bit the disadvantage or the other side actually of subsidies, right? A lot of these projects now can run based on subsidies, while if you take them away, we are really looking at the most cost efficient and energy efficient routes. But it's a good start, but in the end, of course, it should all work on its own.
Okay, thanks. I would jump to so the fact that we are now sitting here, three different system providers. You're speaking very much the same language, but the different systems have different functionalities and ways to capture. I mean, we haven't really talked about collaboration yet, but maybe as an element of how we get there and move from this short term to long term, which you, Alisha, say that there's not so much distance between where we are today and where we will suddenly see this scale. What's required? I mean, we talked about regulations already, but beyond that, I mean, how do we get there from your side, Alisha?
Yeah, I don't think it's that difficult, and maybe I'm an optimist, but I think what's required initially is a few pioneering owners, like credit to Lomar, for instance, for doing the first pilot with us, right? That are interested and enthusiastic about sort of breaking down the barriers and trialing new technologies. So I think it just takes a few of those to really get these systems out on the water and to start to prove that they work, prove the business case, and also to start to drive the technology down the cost curve. I think that will be sufficient to get started. And for our system, for instance, we don't need liquid CO2 pipelines in ports. We don't need lots of fancy infrastructure. We basically just move rocks around, which we know how to do. So it's pretty simple to roll it out. In terms of then scaling and how we increase beyond that, I think that's where we do need the regulatory piece to help get the whole industry moving in the right direction. But I do really believe it's coming, and I think there's even pockets, even if not globally, there's pockets in the EU, in the US as well, with the Inflation Reduction Act, where these systems already do start to make sense. So I think we're already heading in that direction.
And then I really wanted you to mention this because I mean that was also news to me. We said Carbon Capture Coalition, right? So there is actually also bodies that are
Yeah, I think so. There's not many of us working on onboard carbon capture. It is a brand new category. So we're a small but mighty group, but we've actually been organizing ourselves into a group called the Mobile Carbon Capture Coalition, which was initially initiated by a company that does carbon capture for semi-trucks in the US called Remora. So we've really been advocating for policy amendments, primarily in the US, a little bit upcoming now for the IMO and the EU. But I think it takes companies like ours to come together and to show this isn't something that's just one crazy startup in London, right? It's many of us working on the same efforts. And if we can get owners, if we can get flags involved with us, then that will accelerate the process as well.
Yeah.
Super. Thanks, Alisha. Yeah, Yvette, you had a follow-up comment on this one here?
Well, yeah, I think that's absolutely right. I think there are two ways for collaboration, right? It's between the technology providers. So we are actually in the same coalition that Alisha just mentioned. And I think that's really important to really push regulatory bodies. If we're not doing that, the changes will be postponed, right? Unless it's pushed by us and the ship owners, it will not be recognized under regulatory regulations. But the other thing also comes from ship owners. One of our clients, actually, they are really promoting us to their competitors, basically, because the more vessels are equipped with carbon capture technologies, it also benefits them in the end. And I think that's a really interesting, you do not see that very often, that ship owners are really promoting their technologies on their vessel because they benefit in the end from
good point. Interesting. An interesting piece of information here on that recommending across to competitors. That's also good practice. Okay, we are slowly running out of time. I want to take the last question, pitch it around, starting with you, Søren, and then I think we'll zoom in on the future outlook of the technologies. And it's always interesting, right? Because it's early stage, but regardless, I also want to try and just jump 5 years into the future and see. So where are we then in terms of both the advancements of the technology and also the application of the technology? So we'll take a round on that, and I'll conclude with you, Steen, not only on carbon capture, maybe also just zoom out a bit and see the technology advancements in general in shipping. What's the journey we're looking at the moment, and what are some of the things that you are very excited about next? I'll pitch it up on a question here from Emmanuel. I'm sorry for not posting your question number one, Emmanuel, but I've actually already covered it through some of the conversations. What are the most promising technological advancements in carbon capture and storage currently being explored or implemented? So let's hook this up on the future outlook, and let's start with you, Søren.
Yeah, I think at the moment, what is most exciting to me is this development of CO2 reception infrastructure, being it for saturated amine solution, like for Value Maritime, which, by the way, could be some point for cooperation, at least for offloading this in China, but also handling the pure carbon dioxide in ports. So that's, to me, the exciting thing going on, because there's huge developments taking place all over the world at the moment.
Thanks, Søren. Thanks a lot. Moving on to Yvette, your views on future outlook.
Yeah, so indeed, the CO2 outlet facilities, that is our main priority at the moment. discussed already multiple times. But the other thing which is interesting, I think, is that we should not look at this as a intermediate solution. So of course we can implement it today for the fuels available in the market today, but also for future fuels. So and that, I think, it's a really interesting development. So even if you install it today for high sulfur fuel oils, the system can also be retrofitted to methanol fueled vessels or other future fuels. I think that's a really interesting development.
Cool. Thanks, Yvette. And then over to you, Alisha. Same question.
Yeah, absolutely. I think I'd echo what Yvette just said. I think it's also interesting when you combine CO2 with methanol, because you actually would have to store less CO2 on board, because I think it's about 2 tons of CO2 emitted for every 1 ton of methanol burned, as opposed to 3 for conventional fuel. So it becomes kind of more viable for that type of fuel. I think the other things that we're really working on are making our system as fit for purpose for owners as possible, right? So it's increasing the efficiency. For instance, the calcium oxide pebbles, you can work on making them more reactive. So you need fewer pebbles to capture the same amount of CO2. So it's really about taking up less space. There's increasing modularity so that you reduce retrofit times, again, reducing cost and reducing time. Another thing that we're looking at as well is actually offloading the carbonate into the ocean. Calcium carbonate is actually the same as seashells. So technically speaking, it's pretty inert. So that's one thing that we've been studying, and we're doing ongoing trials for that. TBD on if that will be the future for us, but I think that's one creative exploration to look at how do we make this as easy as possible for the industry to adopt. And then in terms of future outlook, so for us, I mean, we're a venture-backed company, which means we're raising money to grow as quickly as possible. Our ambition is to have CO2 capture systems on 1,000 ships by 2030. So I think to your question of where will you be in 5 years from now, we should be in the hundreds of deployments per year stage in 5 years from now in order to hit that 1,000 by 2030 target.
Thanks, Alisha. And just jumping back, so you're actually exploring whether you can basically dump the pebbles over the side of the vessel into the ocean. I mean, in theory, right? Okay, then it makes it even easier.
There's definitely a regulatory question there, and then there's also a science-based question in terms of what else are the pebbles holding. But given the reaction time, it doesn't seem like they're particularly contaminated, so it's basically the same as seashells. But yeah, more to come on that. Not our go-to market, but potentially development.
Okay, super. Thanks, Alisha. Then concluding with you, Steen, both in terms of how you see carbon capture developing over the years to come, and also what else is out there. What are you scouting for in terms of the new, you could say, disruptors in terms of technology for the industry?
First, I'd like to comment that there's a lot to do on the technologies that have been in existence for a long time. So kind of the core of Njord is to, ensure the adoption of these technologies, and this should proceed. But on the newer technologies, I do foresee that wind is going to play a lot bigger role in the future, potentially also air lubrication. And then we are piloting vessels that are fully hard-coated with super slick hard coating, and pairing that with hull grooming ROVs, so you can ensure that the performance of the hull is at the best at all times, and you don't have these losses until you clean the vessel. So that's I think is going to grow quite fast. And then a comment on Alicia's pebbles and dumping into the sea until regulation is in place. I'm in contact with a company that's actually converting seashells into artificial reef material. So there is an alternative way to dump it in the ocean for increasing biodiversity and so on. So we're going to have a talk about that, Alisha, at some point. I think it's a very beautiful circularity thing that can be involved here. It's a 3D printed artificial reef material, and the feedstock is seashells today. So if they are to expand, they need more feedstock. So that could be a beautiful relation. But yeah, we also look into technologies that further enhance the hull performance. So not just maintaining the hull performance, but you can further enhance it. And we hopefully have some pilots going on next year on that. So there's lots of things emerging, and this increased focus on climate crisis and all that, there are so many companies, inventive companies that are exploring the maritime industry. And we are going to see some very interesting developments the next 5 years, for sure.
Thanks a lot, Steen. Some encouraging future outlooks here across the board. That concludes our live events, and that leaves me with the thankful task of trying to recap what we've been through. And I'm not sure, but luckily, again, the recording will be online so people can actually see it. Some of the key notes that I've taken as we went through is the current application. We heard from Value Maritime, the 21 systems applied. And more to come in 2024. We heard about orders being confirmed with a UK owner and a Greek owner from Sinotech. And then we heard about a pilot, without spilling too much the beans on that, from Seabound. So there's definitely traction in terms of implementation of the systems. We've heard about results in terms of carbon captured so far, figures between 20% and 40%, but in theory and capacity-wise, all the way up to 90%, which is quite encouraging. And then we also talked about that one of the constraints is storage, and also usage, tradability, and making it a commercial viable business case. In connection with that, we talked about how carbon capture fits into the current regulatory framework, where the EU and through the ETS scheme has said yes to carbon capture if it's being permanently stored, but we have hopes that throughout 2024, it will also include thoughts around reutilization or circular usage of the carbon that is captured, whereas the IMO has also established a working group to ensure that carbon capture is catered for in their regulatory framework going forward. And we talked a lot about if the business case is not entirely there yet, then what are the considerations that the ship owners should do? We talked about linking it up to a scrubber business case initially, because there's good combination opportunities there for the different systems. And then we also talked about that it is important, if you want to stay competitive long term, to get your hands dirty already now, start the relationships with the different suppliers, and figure out what is the right path for you when it comes to carbon. And then with the overarching thought that we should also actually stop looking at CO2 as a waste, but rather as a commodity, and figure out how we can make a good business case out of that, because there are some really good thoughts around that. We also talked about that this is something that makes a lot of sense to combine with other technologies out there. There is an energy constraint, energy penalty for some of the systems, but that can be offset with some of the more traditional systems. You don't have to necessarily go crazy with air lubrication and wind technology, and Steen's reflection on the fact that the industry haven't necessarily also onboarded some of the very basic stuff that actually works and could be a very good kick to the carbon capture systems as well. And then we talked about the future outlook. Good luck on the 1,000 applications on 2030 for Seabound as an example. High ambitions, both in terms of getting systems out there, spreading the word, collaborating to make it happen, to push the regulatory frameworks, but also to be creative in terms of utilization of the carbon. So the infrastructure, which is needed for all three in one shape or form, can be eased into the industry. And then final note is that we don't see the constraints of utilization on board. Actually, the crew should be very well positioned to manage and handle the carbon capture systems. That was my run through of the key topics. I'm sure that there are more, but there's also recording if people want to re-engage. So that concludes it. Looking forward from Njord's perspective, we've seen a rapid growth interest in our live events. So we will naturally continue this series in the beginning of 2024 here on LinkedIn, where we will, amongst others, focus on other novel technologies. Steen, he shared some perspectives of that already. We will look into case studies of combined energy-saving technologies with industry experts. We will deep dive into the installations that Njord have done with owners and charters in 2023, and much more. Our LinkedIn page is also where you will find a link to the recording of today's session and much more information on the energy efficiency technology landscape that we work with in Njord together with ship owners and charters to accelerate their transition by assessing, designing, and installing combined packages of energy efficiency technologies. And if you're eager to get started by assessing the savings potential of vessels in your fleet, then you have the opportunity to scan this QR code, which is up now. This is a link to Njord's complementary technology screening, which will help owners and charters highlight the number of relevant technologies on specific vessels, the combined technology savings, the cost of the technology package, and then the return on investment. So in short, follow the link to have or get the opportunity to get started to assess your optimization potential already today. Then I want to finalize by saying a big thank you to the panel for a very engaging and insightful discussion. It was a real big pleasure to have you here today. And then I also want to say a big thank you to everyone who dialed in and for the many questions posted here in the chat. I hope this event proved to be useful and insightful. And as mentioned, stay tuned for our next events in the beginning of the year. Goodbye for now.
Thank you so
Bye.
much.
Bye.
Thanks for having us. See you later.